Which page am I on? I'm on 11. Okay. So let's see what we can do here with this. Okay, 1, 2. 1, 2. Negative 3, 2. 1, 2, 3, 2. Obviously, the major axis must be horizontal. Oh. Sorry. So one more time. 1, 2. Negative 3, 2. The major axis has to have the foci. It must be horizontal. So this is F1 and this is F2. Where is the center? Exactly in the middle. So the distance is 4 units. 4 units divided by 2. Right here. Can anyone identify the coordinates of the center?
Two, 2.
So this is 2 units. And this is 2 units.
Oh, 1, negative 1, 2.
Excellent. Indeed, negative 1, 2. I already know that this is x minus h, everything squared over a squared plus y minus k, everything squared over b squared equals 1. How come? This will be bigger than this because I already established that the ellipse has the major axis a horizontal axis, not vertical. So it has to be this situation. I have determined the coordinates of the center. So this is negative 1 and this is 2. Now I have to determine A and B. They are telling us that the vertex, at least one of them, is at negative 4, 2. 1, 2, 3, negative 4, 2. So this is V1. Where is V2? So if this is negative 4, the distance between the vertex and the center is 3 units to the left. I have to find the other vertex 3 units to the right. 1, 2, 3. So this is at 2. And this is V2. V1, negative 4, 2. V2, 2, 2. Good. So we have the center. We have A. Can anyone give us how much is A? How long is A? From the center to the vertex, either one of them. How many units?
3.
Perfect. So then this number is already identified to be 9. This number is identified to be negative 1. This number is identified to be 2. All we need to determine is B. And we know that B squared equals A squared minus C squared. A squared is 9. C squared is the distance between the center and any of the foci. 2 squared, 4. So then B again is the square root of 5. 9 minus 4 is 5. B is the square root of 5. So therefore, I have that 2.2 here and 2.2 here. So I'm ready to graph it. So we have it. Now we have to write the equation. X plus 1, everything squared, x minus minus 1 over 9, plus y minus 2 squared over b squared, which is 5, equals 1. And this is the equation of the ellipse. Any questions? I was hoping I have 4 minutes. You're only responsible to work on a 9.2 and 3. But I just want to at least start and show you the equation of the hyperbola, the last item on the list in chapter 9. I just explain what it is and how it looks like. I don't like the graph, the way the book is graphing this at all. So x squared over a squared minus y squared over b squared equals 1. Very similar to that, but minus. If it's minus, the the hyperbola will have the transversal axis horizontal. And this is the conjugate axis, transverse axis, not minor or major or minor, transverse conjugate. So the way I will show it is we will create a box. This is not part of the hyperbola. A will be this. That's why I graphed dashed. B will be this piece. We will draw two asymptotes. Notice through this corner, through the origin and through this corner. Through the origin, this corner of the box, this corner. Okay. And then we will graph the hyperbola. This is the actual hyperbola. Everything else is helping us graph it. And this is the vertex, one of them. And here is the other one, right here. So this will be the V1, this will be the V2. And where are the foci? Well, this is like a parabola. So here is F2 and here is F1. This is how a hyperbola looks like if it has minus in front of the term with y squared. If these are reversed, then it will look like this. So foci, vertices, center, asymptotes, two oblique asymptotes. That's how the hyperbola looks like in this case. And very similar when the minus is in front of x squared, like y squared over a squared minus x squared over b squared equals 1. How will it look like? And I'll stop, promise. Again, we will draw the box first, the asymptotes through the origin and through the corners of the box always. So here, here, and here. Here, here, and here. And these are asymptotes. And in this case, this is the vertex. This is the other vertex right here on the box. And then asymptotically approaches. It's not like a straight line, of course. Asymptotically approaches the asymptote. So again, the foci somewhere here and here. F2, V2, the center, and of course it can be anywhere. And we can graph regardless if it's opening to the right and left. but the vertex is right here on top of the one of the sides of the box. So it can be centered anywhere. So we're going to have examples on Wednesday, examples like this and examples like this, and then we can wrap up this chapter. I hope I didn't hold you too much. Sorry.